Hey everybody, this is lesson 6. We are getting a deep dive into how a neuron fires today. So if you are confused after this, don't be a little bit surprised because this is confusing, takes a little bit of time, and I'm going to try to provide the resources that you need so that you can get this done. There's a video that Hank Green has, so I'll attach that as well so you guys can watch that as well, and I would strongly recommend that. But I'm not going to do that inside this video. So let's set up the situation. We are wanting a neuron to be ready to fire, and we're going to watch what happens when it fires. And what we're doing is actually focusing in on a very particular spot along that long skinny part of the neuron we call an axon. So what we have here in this diagram, you should recognize this. These are the phospholipids, so that's the membrane of the cell. And what we're going to imagine here is that this is the inside of the cell down here, and this is the outside of the cell down up here. So if you remember from last time, we have this sodium-potassium pump. And the sodium-potassium pump, it's not pictured in this diagram, but what's going on there is that sodium-potassium pump is pumping tons of sodium outside the cell and tons of potassium inside the cell. And so what we're going to watch what happens is what are we doing when we actually allow some of those to move in and out of the cell. So we also have to follow along over here, because this is our little graph, and this is showing you what is called an action potential. The action potential is that part that spikes up and then spikes back down and gets back to normal. So we're going to look at the first phase of this, which is called depolarization. So when you're essentially taking the charge of the cell and flip-flopping it and turning it inside out. And what's going to happen is that you're going to trigger, when the nerve is triggered to fire, you're going to open up these gated channels. And remember, we have lots of sodium out here and lots of potassium in here. And so when you open these gates, we're actually going to have sodium rushing into the cell. We're also, at the same time, going to have potassium coming out of the cell. And you might think that, okay, well, shouldn't that balance each other? But remember that 3 sodiums for every 2 potassium. So the force of the sodium coming in is actually much, much stronger. And there's other reasons for that too, based on the electrical gradients. And I know that's a little bit confusing, but sodium is going to come in very fast, and potassium is going to actually go out a lot slower, which causes this change in voltage right there, which we call depolarization. So I'm going to flip to the next one. So here we see, here's that sodium coming in. Here's that potassium going out. Notice the arrows. The potassium is going so much slower. Sodium is coming in much faster. The gates are much more quick to open up. Okay? But when we actually get to that top point, where we actually change the voltage so much, what we're actually going to do is trigger this gate right here. These gates at the bottom of the sodium to actually close. So there we go. We now close this gate. So sodium has to stop coming into the cell. When sodium stops coming into the cell, the only process that is occurring is the potassium going out. And the potassium going out is actually going to change the voltage again. And it's going to actually bring it back down to the bottom. So that is what we call repolarization. So you depolarize and then repolarize. Potassium is pouring out of the cell. Again, that's the only thing that can happen since these sodium gates are now closed. And eventually, when we get back to under that bottom area, we actually flip-flop these gates. It doesn't actually change anything because we still are closed, but it's just that we open up the inactivation gate and close the activation gate, no matter what, sodium doesn't actually enter the cell anymore. It's still closed. But we're just getting back to the beginning here. Potassium is still open, and we're still allowing potassium to actually go out of the cell, which is why we actually have that little extra dip there, which we call hyperpolarization or after potential. But eventually when we get down there, we're still getting that potassium out, that after potential. And then eventually when we get down to the bottom there, it causes the potassium gates to close up, which gets us back to the beginning. And we now are back at resting potential. That whole process is what happened as a nerve signal shot past this area and is moving on down the axon. We'll talk a little bit about how that is propagated down the axon so that you can actually make it move. Because right now we're actually focused on one spot. We're not actually moving with the action potential, but we see what's happened here. This is a nice little video that does a good job, I think, of explaining that. And I am going to hopefully turn down the sound. Let me make sure that I have the sound down. Yep, I have the sound off. So what's happening here, those pink little balls there are sodium. There's lots of it on the outside, very little on the inside. And then we have our potassium that is concentrated highly in the inside of the cell and very little on the outside. There's our action potential, that little glow of light. And what's that's going to trigger is going to trigger those activation gates to open up. Okay? And you'll see sodium comes rushing in. And the next thing that's going to happen is our potassium gates are going to also open, but they're a little slower to open up. Okay, and like I said, the sodium moves more slowly than the sodium. So we're now into depolarization. And we've gotten to the point where we actually have depolarized the cell because of all this sodium rushing into the cell, change the voltage on the cell. And that's going to get to the inactivation gates closing. So now we're sort of at the top of that curve and now heading back down. Potassium is going to continue to diffuse out. Okay, we get back to that activation and open, but again, that doesn't change much. We're still allowing potassium out of the cell, which is going to get down to the bottom, that hyperpolarization, that little dip at the end. And eventually we're going to get to a point where we close those again, and we are back to the beginning. And that cell is now prepared to fire again. It will take a few milliseconds. A neuron cannot fire and it cannot fire over and over. It does take a few milliseconds between firing that it actually can fire once and then fire again. So that video was helpful. I'll play it one more time real quick just to show you in fast forward. I'm going to sort of slide it along. And what we see is that we open up these sodium gates first. That's the first thing. Sodium gates open, sodium comes rushing in, followed by potassium gates opening up, followed by sodium gates closing right there, potassium still open, and eventually we're going to close those potassium gates and get back to normal. Okay, all of that happens very quickly. I will also show you that Hank Green video, and that should help as well. So if you're a little bit confused, the worksheet we give you today I think is going to help a little bit as well. All right, thanks.